about verification of trigonometric identities. This differs a little bit from simplifying identities because now we have two sides. Sometimes this is a little bit easier because you kind of know where you're going. I'm giving you an equation. It's going to have an equal sign. One side is going to be transformed into the other. Okay, I'm put a little note. Make sure that you only choose one side to work with. And in class, I showed you that you could work on both sides, but at the end, you have to erase one of those sides because you can't have work on both sides. It has to go from start to finish on one side of the equation. Okay? So the equation we're going to work with is number 4 from your worksheet. Here again, I wanted to take something that was a little bit more complicated than some of the rest of the problems, so you could see the different tips and techniques that go into something like verification. So we're looking at 1 plus cosine of phi over sine of phi plus sine of phi over 1 plus cosine of phi equals 2 cosecant phi. Now, the very first thing that I think about, and this is on your sheet about your tips for verifying, is you see two fractions here on the left side equal to one little tiny piece on the right side. Anytime that you see this, it's always a good idea to at least try to find a common denominator and combine the two parts into one, because you know at some point in time you're going to have to make these two pieces come together because there's only one piece on the right side. Alright, so the first thing we can do is find a common denominator. Now this one isn't so nice because you have sine of phi on one side and you have 1 plus cosine of phi on the other. Okay, the only thing you can do is simply multiply the two denominators together, and so we're going to end up multiplying this whole fraction, top and bottom, by sine of phi, and this top and bottom by 1 plus cosine of phi. So here I've kind of written in, ignore the colors for just a second. You can see this side you're multiplying 1 plus cosine of phi times 1 plus cosine of phi, top and bottom. And here you're multiplying sine of phi on the top, sine of phi on the bottom. Okay, now notice the red box. Whenever you have two parts, okay, you're multiplying a binomial times a binomial, you're always going to FOIL. Now when you multiply sine times sine, that's easy, that's sine squared. When you multiply the bottom together, it's going to be just sine plus sine cosine. But when you do this, you have to actually FOIL it together. Okay, and I've done that for you here. Okay, so the red box, when you FOIL this together, you're going to come down to this. Okay, now this may look complicated. It's actually not that bad. It's just keep each part organized and multiply it together. And then you're going to collect like terms if you have any. Okay, so once you multiply this together, you'll see that you get 1 plus 2 cosine of phi plus cosine squared. The green box, of course, is just sine times sine, which is sine squared. And the bottom, now, notice I didn't multiply the bottom together. Generally, I don't really want to multiply things together unless I really need to. And sometimes I'm hoping that before the thing is over, I can get some things to cancel out on the bottom. So hold off on multiplying the denominator together for now, and if for some reason later on it doesn't cancel out, we can multiply it together then. Alright, so looking at this step, I have 1 plus 2 cosine of phi, cosine squared of phi, plus sine squared. Okay, now I'm going to get rid of these boxes for a second. And you can see, look what happens here. What is cosine squared plus sine squared, or sine squared plus cosine squared? Well, that's my basic Pythagorean identity. That adds to 1. That would be a lot simpler than having all that cosine squared, sine squared, plus and the 2 cosine. Let's go ahead and replace that with this. This is much nicer. Okay, take this, you know, those two things combined, as you can see at the bottom, it gives you the 1. So I went and I plugged the 1 in where I had the sine and the cosine together. or the sine squared cosine squared. Okay. Now automatically you look and you think, okay, well that's easy. I can see that the 1 and the 1 can combine. Okay. Anytime that you have a chance to collect like terms, that's always a good idea. So if I collect like terms, you see the 1 here plus the 1 at the end can combine to give me a 2. I just put it out front. You could have put it at the end. Doesn't really matter. Okay. One of the reasons I did put it out front is because I'm looking at the bottom of my fraction, and automatically I'm thinking, okay, maybe I am going to get something to cancel, because again I have a number plus a cosine, and that's kind of why I have it at the bottom. All right, and if you're thinking ahead, you're thinking, hey, you can factor out a 2. That's a good thing to do. Once I bring that down, I can factor the 2 out of this part and this part, and bring the 2 out front. That leaves you with 1 plus cosine of phi. Okay, remember if you multiply them back together, you'd get exactly what we had at the top. And you notice, hey, there's something that's the same on the top and the bottom. I can cancel that whole part, the 1 plus cosine of phi, out. Okay, the next step would be seeing what's left over. Well, the only thing we have left here is the sine of, 2 over the sine of phi, right? If you remember, when you have a number on the top, well, that's exactly the same thing as saying that number times 1 over the denominator. So these two fractions or expressions are exactly the same. 2 over sine of phi is the same thing as 2 times 1 over the sine of phi. All right? Now let's go back to look where I'm trying to get to. I wanted to get to 2 cosecant of phi. Right? I've just kind of been following my nose here for a little bit. So we come back down to the end and we see, well, isn't that interesting? Because 1 over sine is exactly cosecant. So I use my reciprocal identity. I'm going to take this part and I'm going to replace it with cosecant of phi. And you can see that here. And so you see the final product when you replace this part with cosecant. You have exactly 2 cosecant of phi, which is exactly what we had on the other side to start with. Okay, go back, watch this again. I tried not to go too fast, but notice that you can always watch this as many times as you want. Take your time. Remember that learning those first 11 identities, which is the only thing we've used so far, really, really will pay off in the end.